Okay. So I have a little bit of a Japanese introduction. Let me do that first. Minasan konnichiwa. Watashi wa Viki no Ishan desu. Kyo wa experimentation framework netsuite ohanashi shimasu. Go sanka itadaki arigatou gozaimasu. Thank you. So while it is loading, I'll just talk a bit about myself. I'm from Singapore, working for Wiki. Oh, there you go. So I'm a software engineer at Wiki, working in the data team. And this is one of the projects that I personally worked on, which is we built our own experimentation framework within Wiki. So I'm going to talk to you about how we run these experiments, why we built our own experimentation framework, the technology side of it, and also the business side of it. So yes. So why do we want to experiment? So this is one of the Dilbert cartoons I kind of like about experimentation, which talks about your intuition may not work. So your intuition may work when you don't have a lot of users, but when you have over 1 million users, let the users decide what they want. Also, if you harp on your customer feedback, you might skew your product into a direction of into something that is meant for users who are more vocal than maybe the majority of your users. And the third point is, this is to get rid of the hippos, the highest paid person's opinion. That may not be the right opinion. So you want the data to make the decisions. So what is A/B testing? By a show of hands, how many of you guys know what is A/B testing? Okay, anyone would like to tell me what A/B testing is? It's like a simple, dirty definition. Anyone? No, okay, anyways. So I'll tell you what A/B testing is. So basically, as you can see in the image, you decide what to test on. You come up with variations of that, and you show different users variations of, like, let's say your sign-up screen, and you figure out which works best. Then you promote that to your permanent screen. So we'll be talking more about this in detail. So as you see, how do you A/B test? So when you're starting a new test, first you sit down and brainstorm. You create variations. So let's say we are experimenting on the home page of Wiki. So we'll create various variations of the home page. We'll start running the test. We'll maybe show 10% of the users variation A, 10% of the users variation B. Then we'll see what is working. So let's say variation B works better than variation A. We'll reach a statistical significant number to prove that. Then we'll promote variation B. So we have a better working variation, and the data decided that, and not any of the product managers or anyone, not anyone's intuition, basically. What can you test? You can test anything that affects user behavior, which is any part of your application. So any part of your application that a user interacts with, you can A/B test it. There's a lot of tools out there. Like you can see some of these, Optimizely. We started using Optimizely at Viki, in fact, and it works great, but it's very limited. You can't do cross-pages, multi-pages experiment. We are not able to tie it to our own data. So we decided that we need to build it on our own. We needed more control. We needed to run many more experiments, many different types of experiments, not just a button color change or UI changes, but algorithm changes. We also wanted to tie it to our own data, and later you will see how we are able to do that. Also, we wanted one framework flexible enough so that we can run it on our Android app, iOS app, web platform, Flash, a Roku platform, Google TV, basically any kind of platform, the one system for this, so that there is coherence. Any questions so far? So I'm going to be giving you time for questions in between the talk so that it's more interactive. And if there's any sort of questions coming up, feel free to raise up your hand. So any questions so far? Any points that you would like to point out? Okay, so let's move on. So we decided to build it on our own, and this is what we did. We call it, sorry. So we call it Turing. And this is sort of the architecture. But let me move on to the challenges first. So what were the challenges in building such a system? First is flexibility, as I mentioned. We want it to be flexible enough so that it works across all our different platforms, even third-party platforms like Roku or a Google TV app. Second is speed. We want it to be really fast because let's say you open your Android app. This is the first call your Android app makes before even loading the home page. So if it takes 3 seconds, the user has to wait for 3 seconds before they see the home page. And this is blasphemy, right? It totally mars the user experience. So it needs to be really fast. As well as speed in terms of running these experiments. The product managers working with the engineers to plan these experiments and getting it up and running as soon as possible. Also, after the experiments are running, reducing the dependency on engineers for changing these experiments and further running these experiments. Scalability, we needed it to scale to all our platforms as well as the number of users we have. And two sort of critical challenges that you would face in any sort of A/B testing platform is user partitioning, because you want to show a certain percentage of your users these different variations you're running. You can't show a variation to 100% of your audience because it's difficult to test and your audience will be confused of what the current UI is. Also stickiness. So while you're running an A/B test, if I as a user see variation A, at least for the whole length of the test, I should only see variation A. You can't keep on changing variations. So this is the architecture. It's sort of a split application. The admin UI part of it is in Rails, and the API part of it is in Go. So the Rails application is basically the UI where the product manager or the engineer can go in and change stuff, create experiments, run those experiments, stop those experiments, look at the data of how experiments are performing. So it's basically a simple Rails app running on contacting a Postgres database, and provides an API for the Go application to sort of pull this data every, let's say, 10 minutes. So the Go app, the reason why we decided to separate these two was initially we thought we'll have the API in Rails, but then again, Rails does not provide that kind of a performance. So we decided to do a completely separate API in Go, and we maintain in-memory caches in the Go application, which of course is implemented through timely syncs. And the Go application itself does not make any external calls. So each request comes in, the clients send a request saying, let's say, hey, I'm an Android app with user ID this, session ID this, tell me what to show the user. So the Go application makes that decision on the server side, serves a response to the clients, and based on that response, the client sort of build these experiments or build the UI for the user. Any questions on this slide?
Why do you use Go over the other languages?
So, great questions. Why do we use Go over other languages? So we looked at a few languages. We were also looking at Node.js. But the way it's implemented, we thought Go would be great at performance, and it has given us great performance. The response time for our server itself is about 300 microseconds on the server side, plus network latencies. So mainly, I think the biggest reason was performance, but I'll go over some other reasons in my later slides.
And so, like, if you want to start it again, you start from like other thing to Go, or you just use Rail and Go again?
If I have to start it all over again, maybe I'll get rid of the Rails part.
Okay.
I'll build the UI on Go as well. So I'll build some JavaScript UI on Go. Because it is sort of a two-system thing, and the maintenance or adding new features becomes sort of, it takes more work because you have to go in and change those systems. So yeah, I would definitely completely do it in Go. So as I said, it's really fast. The server response time is about 300 microseconds. So these are the sort of design decisions we made, thinking just to make it really fast. We're going to do it in Golang. Everything is going to be in memory. And we don't want to make any external calls that will slow it down. Not even like a Redis cache. Sorry. So to your question, so these are the sort of advantages that we looked at and sort of found out while working on it as well. So you can compile it and run it as a binary anywhere. So testing on staging and stuff became super easy. Static type checking, so it reduces runtime errors. So when you're writing Go code, it won't compile if there's a dangling variable somewhere, and a lot of these kind of things. It's also a very good trade-off between performance and development speed. So it's a very easy language to pick up if you have certain background in C, C++. So you can pick it up in a day and start programming in it. Of course, it takes a while to master the language, but you can start building apps in it, and like the development speed is really fast, as well as the performance gain is really fast as well. Maybe like I would say development speed is faster than Node.js if you're not familiar with that kind of paradigm. We also use Docker for deployment. Some of the advantages of Docker are that development, staging, and production environments are exactly the same. Portability is great. I think I've migrated this whole application thrice, and every time it takes less than half an hour to migrate the whole application. So we've been really happy with Docker. Also modularization, like every app is its own container, and it can exist on machines with other microservices that we are running. Any questions so far? Okay. So coming back to stickiness and user partitioning. So a simple method to do user partitioning is basically hashing the UUIDs. So UUIDs are unique identifiers for each user, something like a cookie ID. So what we do is we hash the user IDs based on some hashing algorithm to one of the 10 buckets. So let's say you divide your user base into 10 buckets, each with 10%, and you basically hash each user into a bucket. So assuming the user UIDs are random enough, which they are, you basically sort of are evenly able to distribute the traffic into these 10 buckets. Now the tricky part is stickiness. So usually the first thing sort of that came to our mind was maintaining some sort of Redis centralized cache where we can store that a user saw this particular variation and keep it alive for, let's say, 2 weeks, as long as the experiment runs. But then again, it's a distributed application deployed over 8 different clusters. So you needed like a sort of a centralized cache to maintain that. So it's difficult to maintain. It's not impossible. But we sort of try to work around it and also try to make it more efficient. So we also hash the variation ID to one of these buckets, and we try to minimize the collisions. So basically, each time the same user sees the same variation as long as the variation is alive, which means as long as the experiment is alive. So a few other design decisions we made. The determination of the experiment is server-side, and also we only show a particular user one experiment at a time, which is sort of going with the A/B testing rules. Because if a user is under 2 different experiments, then you cannot tell that the change is due to experiment A or experiment B. So how do we create these experiments? So we have a few of our own terminologies. But basically, a feature is something that you want to experiment on. So let's say a homepage, right? A homepage of an Android app is the feature. And then you have different variations of the homepage, so variation A, B, C. But here's the tricky part. So we wanted to extend our A/B testing platform into something more, into something where we can do customizations, different kind of experimentations. So we came up with this 3 types of variations. The first one is experiments, the second one is settings, and the third one is default. So a default variation would be the base variation, the original control variation. Setting would be, let's say I want to show variation A of my homepage to all my Android users in US. So what I can do is I can create this variation as a setting and give it all those conditions. So 100% of my US users on the Android application will see this variation. So you're customizing your application based on certain conditions. And then comes the experiment. So it's very similar to settings where you can set these conditions saying my iOS users in Singapore will see variation C, but only, I'm sorry, only 10% of that group will see variation C. So you don't have to expose all your users to it because you're still in experimentation phase. So what happens is when you're running these experiments, you sort of loop through each feature, and then you go to variations. So for, let's say, the homepage feature, you first check if there's any eligible experiment for the set of conditions that the client sends in. So let's say the client is a US client of Android. So we see if there's any eligible experiments. If there is, then we see if the user is eligible for that experiment, as in if the user falls in that 10% bucket. If not, we go on to the settings, we see if there's any eligible setting. Again, if you have an eligible setting, you show the setting. Otherwise, you come back to the control, which is default. Any questions here? Is it clear? I know it's a bit confusing, it's our own terminology. So feel free to ask. So this is an example. So just sort of an exercise as well. So the default version of the homepage is 0. And we set a setting saying all the country US will see version 1. And version 2 is the experimentation version. We say country Singapore, starting time today to tomorrow. So basically for 2 days, we'll see variation 2. And country Singapore, for today to tomorrow, will also see version 0. So this is 10% of this traffic and 10% of this traffic. So if you're coming from Japan, which variation would you see? Anyone?
0.
Yeah, 0, right? If you're coming from Singapore, which variation would you see? Depends, right? So it could be
2 or 0.
it could be 2 or 0. So basically, it could be 2 with a probability of 10%, 0.1, and it could be 0 with a probability of 90%. So okay, so you guys get it. Any questions?
Can you deal with user attribution such as gender, age?
So right now we don't do gender and age, but we based on the type of user. So we let's say if a user is a new user versus a return user, we can show them different things. But the tool itself is, yeah, it can be extended to gender, age, any kind of user attribute, and we can customize it based on that.
I mean, which group is better to test on? New users or returning users?
Well, it depends what you're testing. So you could have a feature only for new users, or you could have a feature only for return users. But generally, we don't, like, if you're showing us a UI change, we generally don't differentiate between new and return users. But sometimes we do. So sometimes, like, we were running a test which was a new user experience test. So we sort of limit it to only the new users. Then again, if you're looking at it, if you want to experiment on something which is video related, so something, for example, let's pick so something subscription related. So some people who've already who are doing some sort of subscription related activity, we might prefer return users than new users. So it really depends upon what kind of experiment you want to run and what kind of audience you want to target. So really, I think the magic of this sort of tool, initially it was, hey, we're building an A/B testing tool, but by the introduction of this different type of variations and by the adding of settings is where the sort of magic came to be. Because now we could do customizations based on countries, regions, user types, as I said, different time ranges and application versions. And we're sort of slowly expanding this list to be able to do more and more customizations across all our apps. So this is sort of a screenshot of the UI. You can see a bunch of different experiments around. Like it's more of a dashboard of the experiments. You can go inside the experiments and see more. And this is like once you click on editing one of the experiments, this is how it looks like. So you have the name, feature, category, you can set different conditions, and this is a sample sort of response object that is returned. You see, and which is what the client understands. It understands, they say, okay, add settings web 3 is the third variation that it needs to run for the ad settings. Sometimes we have like complicated JSONs where you actually have all the information there. Like for example, a homepage experiment, we actually return in detail even this sort of copy changes that the client needs to show. So it's how much control you want from the UI. We make it by having a JSON, we make it completely flexible for the product manager to decide what contract they need to sort of send to the client. So it's a contract between the product manager and engineer. We give them complete flexibility to do that.
You guys have like a standard vocabulary or grammar for use?
We don't. We've thought about it. So we've thought about introducing some sort of a DSL. But for now, since it's being used by so many different clients and so many different product managers, they tell us that it's okay, like let it be flexible. So for now, we're keeping it flexible. Maybe in the future, if we see some sort of abstraction, we'll introduce some sort of language. So how do we collect data? So as you saw, the clients make a request to our Go application. The Go application sends them a response, which is basically the data response that you saw, and the client builds the application based on that response. It also lazy sends some sort of data to our data collector infrastructure. So it looks something like this, that hey, user this, user ID 1U under session ID this, saw this particular experiment, and also basic information, contextual information about the app and the user and stuff. So we can tie this information out to any sort of user-related information or session-related information, which is exactly what we do. So here are some experiments that are running, homepage and some other experiments, and we're tying it out to video starts. So this is something you cannot do in other external A/B testing tools, right? So we're trying to see, okay, based on these changes, based on these experiments that we're running on different components of the app, how does it affect the video starts in the same session? So are they going up? Are they going down? So clearly we can see like the red experiment is performing way better. Also to make it faster, we introduced this sort of concept where and faster and cleaner actually, every release that you do with your different clients like Android, iOS and stuff, you mark the features that went out with it. So when we get the information on the server side, we only sort of have to run through those features and not all the features. It's a small optimization. Any questions so far? Oh, okay. So sometimes the users define the product. So while building it, we try to make it as flexible as possible, so that sort of our product managers and our engineers can decide what to use it for. Because frankly, we weren't very sure what exactly we are building. It was like an A/B testing framework plus. So these are the kind of things that they use it for. So one is feature toggling. We released our in-app purchases on mobile, and that was one of the features that was used. You could basically turn it off and turn it on anytime you want. And I think there was a bug in one of the features that got released. So we quickly turned it off, and we were able to save like at least a good week of our app crashing, because iOS push cycles they take a while. Right? Also feature tweaking and improvement. So if you see on a video website like Wiki, or if you're familiar with YouTube, you have this upcoming banner, so basically the next video banner. So we wanted to see when to show that banner. Should we show it at 90% of the video, maybe like 50%? So we basically tried like a bunch of different combinations, and we tried to optimize it and sort of tweak it over time. Then feature customization, we show different stream qualities, different base stream qualities of video based on the country you are in, because of general average network speeds in different countries. slow feature rollouts. We released the new recommendation system, but we only released it to a certain percentage of US users. So it was a very slow rollout to like 10%, 20%, 30% US users, and we kept on looking at the data, how it's performing compared to our previous recommendation engine, how are the click-throughs, how many video starts it's driving. So instead of just exposing all our users to this new algorithm, which may end up doing something crazy, but it was like the new experimentation, the new recommendations is running and it's been performing very well. Also in-app messages, so product managers started sending messages on mobile platforms through this platform. So they set a time range, they set a setting, and define a message like, hey, this new TV show has released, and they're using sort of our A/B testing platform for the same thing. So these are some of the experiments we ran. This is a Wiki Pass landing page. So Wiki Pass is our subscription where you can buy I think it's $3.99 a month, and you get no ads, exclusive HD quality, and on the go. So we ran like, I mean, this is very critical, right? This is where we're making part of our money. So we want to drive more users to click on sign up now and be able to complete that transaction. So we were trying different versions of a page. So this is one of the versions. This is the second version, and this is the third version. Any guesses which one? Hands for the first version. Okay. Second version? 1%? Okay. Third version? Okay, so third version seems to be the most popular. But the winner was the first version. So as I said, like it might be very counterintuitive. Like I would personally think the third version as well because it's more visual and it sort of tries to get you that click, right? But apparently maybe people like more information because they're about to pay $4, so they want to see what they're getting out of it. Also, we ran a bunch of experiments on the homepage for Android and iOS to optimize clicks on the homepage. Because it's a small real estate, it's just a small screen, and everything that you do on that screen makes a difference. Your text, your color, the size of these lists, the order of these lists. So we tested a lot of different things where we were changing the carousels, the copy on this, so popular TV shows versus popular global TV shows, and we were trying to see what works. So we ran a bunch of experiments, and we were able to drive 20% more conversion rate, which is 20% more video starts from the homepage. So this is our third experiment. It's basically ads optimization. So when you see videos on YouTube or Wiki, you see different ads, right? And no one likes ads. I mean, the users. We like ads because we make our money off that. Right? So there has to be a balance where you don't get pissed off enough and we make enough money. So we're trying to strike the exact same balance. So as you can see, there's like these ad markers, and then there's different ad markers. So there's more ad markers, but there's so many different configurations in which you can show a user ads, and also it depends upon the kind of content you are showing them. So it could be a news clip, which is 3 minutes, versus a movie, which is 1 hour or like 2 hours, versus a TV show, which is maybe 40 minutes. So we sort of experiment on all of these different things. Maybe show them a pre-roll, or a pre-roll with like 2 mid-rolls, or maybe no pre-roll at all. Let them get into the video, let them get into the show, and then show them like 3 ads at 10 minutes. So it's a lot of different combinations. We've been running this for about like 4 months, but 3 months, and we've been trying to see what's the most optimal configuration. And we've found a lot of interesting stuff, but I don't think I can share it here. But this is how we sort of analyze and look at it. So as you can see, this is one of the experiments that's running, and we compare it to the control experiment, which is the base or the original configuration. So as you can see, we looked at different things. The users that saw that experiment, the ad starts that were driven by the experiment versus the control. How did it affect the number of video plays or video starts? And also, how did it affect the number of minutes viewed, which is sort of a direct measure for engagement. So as you can see, the video plays or the video starts and the minutes views are not affected that much. It's a very small change, but we're able to get 17% more ad starts, which is 17% more revenue for the company. So that's huge. And we're able to do that because of all this experimentation. So also, we're still figuring it out. We sort of built it out as a A/B testing platform, and it's much more now. And we're looking into other stuff as well. Even yesterday, we were talking about, at RIT, we were talking about multi-arm banded algorithm, and that seems very exciting. So, yeah, we're quite excited about it. And if you have any suggestions, also come up to me. We can talk, and maybe we can learn from each other. Yep. Thank you. That's it for me. Any questions I can answer? Robert?
Are you able to take care of some side effects like dilution and that kind of problems in A/B testing with that framework?
What do you mean by dilution?
Dilution is when the user actually doesn't see the feature, so you don't, so you measure maybe some increase in CVR or something, but actually it's not due to the feature since he hasn't seen it. Like for example, they had this problem in Twitter where they introduced new tabs, but the user wouldn't swipe to the new tab. So whatever was measured was not actually an effect of the feature.
So while measuring, since we're running like multiple things, settings and experiments, while measuring, we always see whether that impression was made, and only then we count it as an impression.
Okay.
And then we see the conversions for only those users or only those sessions where the impression was made. That is for dilution. Any more questions regarding technical, non-technical experimentation? Okay. Cool, thank you, thanks a lot.